Hello, my name is Garrett, working with the DLASC, and today I want to go over some domain range problems with you. So these typically, the ones that you'll see here, are what you'll see mainly on an exam, and these are some of the problems that you would probably typically see on one of your exams. And you'll have it something like this, where you have a domain, you have a range, and then it'll ask you what the function is, right? And in order to answer these, we'll have to know what a domain and a range is. So if you have a graph, say something like this, right, over here to the side. What your domain is defined as is all your x values. That would be your domain. So everything that lies on the x-axis, not lies where it connects, but lies where, let's say you have a graph like so, your domain would be where it starts here all the way to here. And because your x-axis encompasses what the graph is going through. And similarly, your range would be defined as everything from the y. So from here to here, those peaks where the y range is encompassed. And so that's what it's defined as, right? And another thing is, let's say you have a graph. Let's erase this one here. That, let's say, is like this. And you see some of them like that with the arrows on the problems here. If you have something like this arrow means this graph keeps on going to the right and to the top, farther and farther and farther, and it keeps going on. And what this means is that it doesn't stop. And so you would have an infinity here, meaning this, let's say it stopped right here at, let's say, -5 here. So what you would have would be -5, and then it goes all the way to the right to infinity. And that would be your domain. So those are the concepts for domain and range. It's what the interval is encompassed by. You want to know it's on an interval. And let's say it's not on an interval. Let's just say it's a point, right? Kind of like this first problem. If you have something like this, well, you can see right here, it's not really on an interval. Your domain starts, all your x values, it starts right here, but it doesn't really go to the right at all. It's just right here. It's a straight line up and down vertically. And the same thing with this right here. So in this case, your domain and your range wouldn't be on an interval. It would just be at those points. And it would be, it looks like -3 and +2. So that would be your domain. And so your range would be all your y values. So it would start, well, in this case, it has these arrows. So it doesn't stop right here. It just keeps on going forever and ever. And what that tells me is your range, all your set of y values, in this case, would be -infinity to +infinity. Because these keep on going forever. And at 2, it exists there. So 2 is encompassed in there, so you don't need to break that up. And for your y values, what I like to do is when I look at my x-axis and to find my domain, I just look at it upright. But for me, and this is just a trick that I like to do, is when I try to look at my y values, which is up here, I like to turn it to the side and look at it like from this way to this way, as from side to side. And typically I find I can get a better visual for what I want to look at. So, but we're going to skip function real quick before I do that. And we're going to let's do the next problem, next two problems. So in this case, right here, you can see that there is a open circle. An open circle, what that means is it doesn't exist right there. And a closed circle, oppositely, means it does exist there. So what this graph is saying is right here at -5, that it's a hole, basically. I like to think of it as there's a hole it missed, and it does not exist there. And right here, the hole's filled in, it exists there. And so from -5, our domain would be from -5 to +5. Now, that circle and that open circle means something. So if it doesn't exist there, the way they want it written is you would have an open parentheses. Open hole means open parentheses. That's the way I like to think of it. And that just means that it starts there, but it doesn't exist there at -5. But over here at +5, it does exist there. And so you would write it as a bracket. Closed hole, closed bracket. That's the way I like to think about it. And so that would be your domain. But you just have to remember that the notation that they want it written as is parentheses and brackets. That's what qualifies it if it's equal to or non-equal to something. And so your range would be your y values. So you would look, and right here it looks like our y starts here at -2 is the bottom right, and it exists there because the line is there and this hole is there. And if you go to the top end, it looks like it goes all the way up to +2 and it stops. And that's the maximum height. So your interval for your range would be, remember the brackets because it does exist there, from -2 to +2. That would be your range. So looking at number 3, this one's a different graph. It looks like it goes up, it peaks up right here, goes down, peaks down, and then it keeps on going. Well, what this tells me this arrow means is it's not going just straight up. It's going straight and slightly to the right up. And it's going to keep on increasing it's going to keep going higher and higher and higher, but slightly to the right, just a little bit. And it keeps on and it goes on forever. And so that's not just telling me it's going up to infinity, but it's also telling me it's going to the right to infinity. And it would gradually keep on going and going forever. So when it comes to domain, let's erase that. When it comes to your domain, and similarly the same thing down here, it's not just straight down, it's at a slight slant. And what that tells me is so your domain is -infinity because it's going to the left forever to +to infinity. And with infinities, it never reaches infinity. So the way you notate it is it doesn't exist there. So they want it written as a parentheses. Even though it's approaching infinity, it might not logically be possible to hit infinity. But maybe that might be above my pay grade. So what you just need to know is for infinities, just keep an open bracket, an open parentheses instead of a closed bracket. That's the notation you need to be using. So let's look at the range for this one. Our range, same as our domain, is not only going to the right forever, but it's also going up and down forever. And so what that tells me is that it has no limit to the interval, and so you will have the same answer, -infinity to +infinity. Okay?